All right. Well, welcome back. My previous lesson, I went through a couple examples of how to use substitution, and I'm going to continue that discussion here. All right. Here we have an integral problem, and once again, how do we know what I'm going to use? I'm going to use parts, whatnot. Well, the first thing that hopefully you see, all right, is you first see if can you use a basic integral. This doesn't look like a basic integral because you have e to the x and secant x. That's not a basic one. So next thing is, can we use u substitution? All right, can we use u substitution? So can we use u substitution? All right, we'll call it u subbing. Once again, u substitution is reverse chain rule. So, and if we're going to use u substitution, that means you have to pick a u. Okay, and that means when you pick the u, you have to be able to take the derivative of that. That'll give you the values that you can replace that are remaining in this expression. Well, in here, hopefully you realize that, hey, look at that. There is something inside these parentheses. It's inside of secant, and there seems to be a lot of e's going on here. It's a little confusing. But I'm going to pick e to the x. Why? Because I see it inside secant. That is a prototypical u substitution problem. I'm telling you guys. All right. So I put that in there. When we do this, we have the integral of e to the x secant of u. All right, dx. Okay. Now from here, what we're going to do next is now we're going to take the derivative of this. Now, the derivative of this, I'm just going to write. I keep on messing up. All right, and I don't know if you are okay with what to do, but we're going to take this with derivative with respect to u. So what we have here is going to be 1. It's going to be e to the x dx du. All right. We have to get the du on the other side. So hopefully what we have here is e to the x dx. All right. And generally, I just always write it like so. But what we have here is we're hoping that what we have left over is e to the x dx. Hey, what do you know? That is what we have. So I'm going to replace that with du. So we have the integral of secant of u. All right. Secant of u du. So now what we have is you now have the integral of secant u du. Now from here, you can look that up, and for my students, usually memorize this secant u. You have to use parts, and I've solved this in the previous tutorial on how to do that. So this is a basic integral that we should know, secant u. When you have that, we know that the integral of secant u is natural log of secant u plus tangent u. Now, if you didn't know that, now you probably want to write that down. You see that a lot, plus c. From here, well, we now have to plug in our u, all right, which is e to the x. So now our final step is the natural log of secant of e to the x plus tangent of e to the x, and all of that's going to be plus c. And I apologize, this looks really, really bad. Secant, c e to the x. All right, and that's our answer. And that's using u substitution. Once again, when you see something inside of something else, that's what you're going to use to solve and put for your u. Well, let's try one more. In this one, once again, we have a fraction. Not sure what to do. It's not a common integral, but maybe after doing a couple of these, you're just like, hey, I think we're going to use u substitution here. Let's try this, because this is probably the easiest thing to do. So let's pick our u. I could try cosine, but hey, I have the denominator here. Let's pick the denominator. Usually the denominator always works out. We don't have anything inside something else, so let's pick the denominator. Let's take the derivative now. Well, if you recall, we took the derivative of u. We're going to eventually put that on the other side, so du. And we'll have over here, this turns to 0, and we'll have negative cosine of x, and there's going to be dx left over, because when we take the derivative of u, this is what we're going to have. Did a little shortcut on how you write this out. This always happens. All right, so du equals this. Well, that's pretty close. So if I plug all this stuff in, I'll have cosine of x dx left over. That's going to be over u. And I have cosine a. That's pretty close. I just need a negative du. I'll put that on the other side. And now I can substitute that in. When we substitute that in, we'll have negative, all right, du over u. And just finish it off. Integral of that is going to be negative natural log of u plus c. What is u? Well, u is simply 2 minus sine of x. So this is a fast, efficient one. And yeah, u-substitution can be kind of nice. What was that? Again, it was 2 minus sine of x. So we put 2 minus sine of x in there. And then we go plus c. Bada bing, bada la boom. That's our solution. See, u-substitution can be really handy, and it's not too hard. Key thing is always try u-substitution. If it's not, try that first. Don't try anything else. All right. Pick use the denominator, or as is the previous problem, something inside the parentheses. They usually end up pretty good. There are some different ones, but this will serve you well. So hope this helps you out. Good luck and God bless in the rest of your problems.